What is up, everyone? This is a quick Kerbal video. Haven't done one of these in a while, and I don't know, I was feeling it. So this is a SSTO satellite launcher that I built, and it's a little oversized for SSTO. I do have a small one, but the idea with this was to kind of recreate the shuttle program without the need of a booster. That way it can take off from the runway. It does use Rapier engines, which is cheating a little bit, but they're really effective, so I was just happy to get that to work. I'm still tinkering around with the oxidizer versus O2. I know I have too much oxidizer, and that's just weight, but it does fly very well, and I just want to show some stuff up on it. So I'll show it in flight here. First I'm going to show this. The center of pressure is much further behind the center of mass, but that's just because as it runs out of fuel, this will scooch up and it will remain aerodynamically stable even with no fuel. It does have parachutes, and that's because it is a heavy buoy, so it needs to be going fast when it hits the runway, and that allows it to come to a stop by the end of the runway. It has some air brakes for re-entering the atmosphere. Vertical stabilizers, very small in relativity to the craft. That is intentional because they add drag, and it really doesn't need yaw, the ability to yaw or anything like that. Fairly big control surfaces for pitching and rotation. If I remember right, no, I guess they're both involved in both. Thought I had one that was set just for rolling, but that would be incorrect. Landing gear maybe could shift up a little bit, but if I remember right, some of the center of mass is due to the satellite, so once it loses the satellite, it's closer to the landing gear here. Center of thrust is all good. And then I'll show some of the insides here. So I do have a very basic communication satellite setup, as well as an extra rotator, like what would you call this, gimbler. On the satellite, it has permanently deploying photovoltaic cells, as well as an ion thruster, some ions, some battery, and that's about it. An antenna for communication and a docker, so it can be grabbed for maintenance purposes. Inside this, I do have a little battery, some monopropellant, and a control panel module, and that's just for setting up for re-entry. I'll show that in a minute, but you can kind of see that battery is at an angle. There's a control module in the front, and when I hit a action group 2, I'll show those. It actually allows it to come in at kind of a steep angle, and that's how it re-enters without burning up. Go over and lastly, on top of all the thrusters it does have a docking port on the underneath of the craft, and I do have a button that will tell it to control from here as well, which helps with docking purposes. So it can actually dock with various spacecraft belly side forward, which is kind of an interesting way of doing it, but it does have the option. And that's mainly because I couldn't figure out a way to put it on the nose that made sense. I tried putting it underneath here, like with the landing gear, and it was an awkward angle, and sometimes things would hit the nose, so I just decided to put it on. Action groups. One is control from the cockpit and retracting these brakes. So if I ever hit the 1 button, it'll fly just like a normal plane would, a heavy one, I guess. 2, it controls from this guy here, which you can see is at that angle, and it extends the air brakes. So that's my re-entry group. 3 is opening doors, both this one and this one. I didn't see a need to separate those because you're in space, there's no drag. You don't risk damage to it really in Kerbal. At least there's no debris just flying through space, hopefully, unless you put it there. 4 is the extending and retracting the photovoltaic cells. 5, controlling from the belly. And I think all of these will be blank up until 9, which is switching mode on the Rapier engines. So with that in mind, Bob and Valentina. So let's take Bob out. And maybe, oh, I'm sorry, I have Jeb and Bill. I got it mixed up. Jeb and Bill, but that's a good combo. So Bill's our engineer. He's going to make sure that this satellite gets deployed correctly and everything. Jeb is our pilot. He's going to get them up into deployment range. So let's pretend we have a theoretical mission statement where we are going to launch a communication satellite at an west to east to do it, and we want to attempt to land, which is always a little tough for me, so we'll see if we can make it all happen. First we'll do our systems check, so we'll turn on our stability assist. We will throttle up just to 1/3, and that is just because this air cone, it can actually power all 6 engines, but it can't do it at start. So if I just hit launch, one of these engines, it's usually this one, would fail, and it would revert over to engine breathing mode. On that note, I'm going to go ahead and pin one of the Rapier engines down here. That way I can see the mode and airflow. When this airflow starts approaching 1, we'll switch over to our boosters. Also want to pin our fuel up here. And we should be good to go. Let me go ahead and toggle the brakes, and we'll... So once we get to 20 meters per second, we'll throttle all the way up. Right about now, air traffic control is going to be giving us the go-ahead. Let's get this up to speed. So we're going to launch this in orbit. to build up for a little bit longer, but with our current trajectory, we will more than get over the Kerman line. For those who are used to orbits, you see most of the work is already done. We're going to have to just kick those, you know, light those fires at the very top of our trajectory here, just to get this parrying upset to 100. But it's almost at 0 already, which means we almost have a functioning circular orbit. And that's not quite right, but what I mean by that is, if this is positive in any way, shape, or form, then we aren't hitting the ground. But of course, we would have tremendous drag, and that drag would pull us out of orbit. It really doesn't take too much. So it's not a functioning orbit, it's just, you know, a circle around the planet, I guess is what I'm trying to say. Alright, I'm going to kick up the engines just a little bit here, just to readjust that apoapse. I'm just going to give it a positive 100 or so, or 1 kilometer or so higher. That way the drag can kind of fight that. We'll just monitor that. We want to get this as close to 100 kilometers as possible. And our nose is pointed in the prograde, so we should just be able to kind of toggle engines from here, at least to get us up into this stable orbit. But yeah, this would be a successful launch. We have 2,200 tons of liquid fuel left, which is a ton. We're on a closed cycle and we have more oxidizer than we do liquid fuel, which is, this is all positive, all good. And so we have more than enough to get up and then get back down. So this would be a successful launch. The question is, can I bring it in and land it? And that is a tricky bit. But I think we can do it. I'm going to give it a shot. Just know that I'm not going to like do 100 takes here to get you a perfect reentry. So you may witness a failure. It's okay though. Failure is part of the Kerbal experience. So I'm going to go ahead and speed this up. I don't think acceleration will hurt anything here. We'll speed up to get over the Kerman line, and then we've just got to burn 5 minutes. So we're above the Kerman line here, which means our drag due to air resistance is negligible. There still is some in real life above the Kerman line, but it's so slight that that's where like the ion boosters and stuff come in, right? Because in real life, you do have to occasionally give it a little bit more energy, but if you had like an actual rocket or something, it would be very heavy with all the fuel and the engine, and it would be very unnecessary. You really don't need much to keep a stable orbit going. Since we're above the Kerman line, we can go ahead and open our bay doors and extend panels. Now we're in the shadow of the Earth, or you know, of Kerbin, so this really won't do much for us. But there's no sense in not having it open. I suppose in real life you kind of want these retracted during movements. It would be a little bit of strain, but we're going to use small burns for adjustments. Try and keep that somewhat realistic. So we'll do a very slow burn here. Kick it up to 1/3 of our throttle. Here we go, that's Kerbal recognizing that we have an orbit. Now we have an above Kerman line orbit. And now we have a very good, stable, circular orbit. You can see we already have, oh, that's a fueling station, so my apologies, I forgot I had one of those up. What we're going to do is we're going to wait until we're into the sunlight in order to do our tests, but we are going to launch the probe, reconnect to it with using the docking port just to kind of show that off, and then we will deploy it, as it were. So we're going to pretend Bill's doing the work on it. So let's go ahead and time warp till we're into the sun. There we are. Now this is more for our benefit. Realistically, we would be expected to be able to do these kind of launches in the dead of night. So, first things first. I'm gonna tilt this bad baby over. And we will go ahead and undock our satellite. Now if we turn our thrusters on, we should be able to and we can go into a docking mode, which should allow us to push forward. There we go, that should be good. Now if we hit set this as target, we hit 5. Let's go ahead and turn those off just so we're pointed towards it. And we'll go ahead and send a signal over to this guy. Oops. Let's go ahead and finish here. There we go. Set as target, and we want to point at target, and we're controlling from the stocking port that I opened up. Go. I turn my thrusters on. They should. Sorry about that. Forgot it's H is for towards with the thrusters. I think it's G for away, or N for away. I'd forgotten that. So there we go. Now we have a positive velocity towards our satellite. What I'm going to do is send a signal over to my satellite and have it just point itself towards the target. Oh, which it doesn't. I thought it would have had gimbals. Oh, we're in docking. There we go. So, satellite is going to point directly towards our satellite. That is all I'm going to allow myself in terms of the computer, so to speak. And we are going to bring it in nice and slow. I'm going to time warp just a little bit here, being very careful with the time warp, of course. It's just this does take quite some time. There we go. We have a proper dock. Now Bill can do his EVA. Or let's say it's not an EVA, let's say he's just working on it through the port. We're going to go ahead and deploy the solar panels. And extend that antenna. And undock it. There it goes. Now we can go ahead and turn on some stabilizers and point it outward. Let's say radial out. That way it's pointed out towards the sun there. And there we have it. Successful deployment of a communication satellite. Very simple stuff. Now, we're ready to... Let's go ahead and close shields here. We're ready to re-enter Kerbin's atmosphere, hopefully with a successful land. That will take a little bit of planning. We can untarget that, I suppose. That's out there. It's fine. Oh, let's go check our map and plan our re-entry. Let's set target. Let's do that. And if we look here, we are looking for the Kerbal Space Center. Now, it looks like we're in a good spot, but we're really not. We would not re-enter nearly in time. I usually try and re-enter from like the back third, if you would. Anything in other and we'll overshoot. So let's go ahead and time warp through an orbit. And that should be more or less fine. So we're going to aggressively drop this thing into Kerbin. So that should be good. Now that may look aggressive, partially because it is, but the rationale for it is we are actually going to get lift once we enter the air. So we'll be skimming across the atmosphere as we re-enter, and that will actually push us a lot further than we'll want to go. We do have plenty of liquid fuel remaining as well, so we'll go ahead and turn those back to air breathing, as we won't be doing any more space burns. And that's plenty to land. So if I don't land this, it's my own fault. Knock on wood. Let's go ahead and time warp just until we're about to hit re-entry. So here's where we want to go ahead and stow our solar panels and close our doors. And I'm going to hit that 2 button. Now that computer I have in here that's pointed down, that is going to give us this nice positive slope on the re-entry. It's also going to turn on our air brakes. And we should be good to re-enter. So, we're coming in very hot. In fact, I'll turn it to absolute surface speed here so you can see. The faster we fall, the faster, we'll speed up. But we are going to have a lot of drag now. So you'll see that surface speed start to diminish at some point. And when it starts to diminish, that's when we're going to be taking on a lot of heat. We can also take a look here just to watch our periaps and apoaps. Our apoaps is going down. That should very quickly start approaching our altitude. All right. We do also have this green flag. That is going to be our runway-ish. It's the Kerbal Space Center. I don't know if that's the actual runway or just the admin building or something. But it is the right direction. So we're just going to point our nose that direction and fly ourselves in and try and land on the runway. Which can be difficult with something this big and heavy, but I think we can make it. You also notice this positive canter we have on the nose. The fact that that's stabilized that way, huge help for re-entry, because that is a lot of drag compared to if we were going nose in. If you go nose in, you're more likely to not burn up, even with this. If anything, these will melt off and then you burn up. You see we're starting to take on the heat, but we are also dropping our surface speed very quickly. Also because of our angle of attack due to this upward cant, we should actually be generating quite a bit of lift, which will help keep us from just plummeting as well. So if we look at that map again, you'll see this line is already reaching way out here, and that's why I like to re-enter really early. Even if we need a little bit of fuel to get over this mountain range or whatever, you'll be surprised how fast you'll fly through this. And a lot of that is just the fact that we are going, like, will this be close to Mach 5? Is that right? Yeah. Alright. So now that we are below burn-up speeds, I'm just going to go ahead and use the energy we have. We can always nose those up if we need to, but we should be fine under that 15 kilometer per second mark. Maybe we need to dip it a little bit more, but you can already see we're not overheating anymore. So this is a good space to be. I'm also going to turn the stabilizer on instead of the velocity vector or prograde tracker, and that way we can kind of maintain our nose, our angle of attack as we come in. So far, so good. Forgot to mention this earlier, but giving these wings kind of this upward tilt as well helps it be very stable, especially on the re-entry. So depending on what you're designing, you know, like fighter jets and stuff, you may not need that kind of bow in the wings, and it may add drag or reduce surface area control or whatever. But for something like this, something that's a little bigger, that is invaluable to keeping it stable, it's just if you level, if we were to, you know, nose to the right a little bit, this would go flat, but this would have a positive vector. So it just kind of helps it remain stable and upright, so you don't spin around. Very useful for stuff like re-entering the atmosphere. So far so good. I'll go ahead and physics warp this up to 2 times, just to help the length of time that this is going to take. I'm actually looking at this. I don't think we're being... There's no way. She's a heavy bird. I don't think we're going to be able to glide over. Alright, well in that case we have all this flat land behind us. So let's go ahead and put it down here. And we'll call it a day. And unfortunately I will not get to show y'all a proper landing. Didn't plan it out well enough. So learn from my mistakes. Maybe not quite as hard as a dip down. Maybe I approached that too aggressively. So, but she lands just fine on rough terrain. She's a little heavy, so we want to keep that speed up. But what that means is we can just get the wheels to touch down a little bit. We will be able to deploy those chutes. She will stop herself. Let's go ahead and reduce our dip in altitude a little bit. Not too much. We do need to keep that speed up. 120 meters per second is pretty ideal. 100 meters per second once the wheels are touching the ground. Oh, here we go. Jeb, time to work your miracles. we approach the ground, gonna nose that up. We do want the rear gear to make contact first. And there we go. I hit those chutes way too soon, but it's uneven ground, so it's hard to tell. And there we have it. Successful landing. Anyways, hope y'all enjoyed. Let me know design ideas and stuff. Changes you think would make it run better. I love to hear. See y'all next time.